when I hear good garbage, I just hear value. There's value in good garbage. I think the path towards getting something that wasn't considered as a valuable and turning that into a valuable, it's art.
Hello, hello. Welcome to the Good Garbage Podcast. My name is Ved Krishna. My primary reason for existence has been to find ways to leave our wonderful planet cleaner. We will be speaking with material innovators, creators, and propagators to learn from them how we can build for scale and towards a regenerative future. Their stories will help us answer the big question: what is good garbage?
So I met Gabriel Salazar, the co-founder of Borgani, a little while back in Guatemala. We decided to have a cup of coffee and a conversation, and what a conversation it was. There is always so much excitement for me in meeting people who are on a similar journey, and Borgani definitely is. They have a great concept of using third-grade starches to reduce the cost and yet make very versatile and effective products. And there is a strong desire to grow. There is so much love and passion that Gabriel brings to this field, and I'm sure you're going to enjoy the conversation. Hello. I'm so happy to have Gabriel Salazar, the founder and CEO of Borgani, with me today. Gabriel and I met very recently, as of last week, in Guatemala. Our producer, Emily, had already done some work and found Gabriel and was very excited for us meeting. And she connected us, and what a wonderful meeting that was, Gabriel. I think time just flew. I think we spent an hour and a half having coffee. Thank you for all the ideas that you came up with and the possible collaborations. And thank you for the work you're doing. And thank you for agreeing to being on this show. So thank you and welcome.
No, thank you, Ved. It was a pleasure meeting you, and I hope you enjoyed the coffee.
Absolutely. It was a good choice. It was. I totally agree with you. Just to kick off our conversation here, let's start with your early life, where you grew up, and if you can think of some influences that might have shaped your current occupation, which is in the sphere of leaving the planet cleaner, maybe something that impacted you as you grew up. It'll be great for us and the listeners to know.
Yeah, I grew up in Guatemala, lived here my whole life up until I went to college in Boston. But I think as a similarity that we all share in the space of sustainability and packaging is we all have stories of seeing pollution in natural, in natural places. In my case, in the Atlantic coast and the Pacific coast of my country, there's a big problematic with solid waste up until now. Now that's a diplomatic and political issue that we have with Honduras, which, so many rivers carrying so much trash into the oceans, and it's become a big issue now. But back then, it's just a natural curiosity of saying, why are these things not decomposing? They last in your hand for 15 minutes and they last in the environment for over hundreds of years. So there was something very, very critic that didn't make sense, I guess. And when you tie that up to being an animal lover, a nature lover, it just bugs you more and more as you see more pollution visually. That's the origin of why I'm in the space, and the rest is a bunch of casualties that were well taken, I would say.
Talk to us a little more about Guatemala as such and the trash situation there. I don't know how many listeners would know much about your beautiful country, so it'll be nice to know from a Guatemala perspective, what is it like there?
Yeah, so thank you for that. And yeah, Guatemala is a country filled with natural resources. It's really beautiful. I don't mean to promote specifically the country, but it's really beautiful. The sights you get there and the amount of amazing flora and fauna you can find there. But in terms of solid waste management, we're way behind, first world countries, and I think it's a general situation in Latin America where you see very little recycling efforts, very little composting efforts, products that are brought to the market and not necessarily adapted to the market in the sense that when you dispose of them, they end up in not wanted scenarios or environments. So I guess in Latin America, we all share that in terms of solid waste management. But Guatemala specifically has a large population for the region. We have 16 million people in the country, 5 million in the city, and only two dumps, two landfills to really control all of that. So naturally, it's become a problem and a bigger issue as we go along. And the latest issue is that one of the landfills grew so much that it's reaching where a river is passing. It's called Rio Las Vacas, which then turns into Rio Motagua, and then Motagua goes straight into the ocean. So there's a big issue there to resolve. And the good news about that is that there's a lot of brain power being put over the last 2 years in terms of really presenting a solution that's viable for the country. But that's a little bit of the background and how we came across doing a solution that didn't require any specific waste handling, because we grew up in a market like this that I just described. So you have to do the most diverse in the most diverse scenarios product to enable its decomposition.
We have so many similarities. I was listening to you and thinking of where I grew up, which was India. Just the scales are different, but so similar. And I think that also had such a profound impact on me as I was growing up. Another similarity that I see is that you went to university in USA, but then you decided to come back to Guatemala. So tell me a little bit about how that transpired and how did the work with your mother start?
Yeah, so the coming back to Guatemala, I think it revolved around being able to give something back to your own community, to your own country. It really served the purpose of being a good testing ground and a good first market for us, because we learned so many lessons from such an informal quote unquote market in terms of solid waste management that it was very valuable for us growing up. The studying abroad, and it's funny because now, after testing and selling in the region, we are aiming towards the North American markets, and that's where the bigger volumes and scales are. But it gave us the flight hours that we needed in order to get a good product on the ground in more sophisticated markets. So, and as you mentioned, I started in a company working with my mom. That was basically a company that traded toys for different fast food restaurants, like the usual suspects, and a couple of other retailers. And I oversaw the logistics part. So I started in really understanding how globalization works, and what to look for in terms of being cost effective, supply chain, and all of that. Really dove deep into that before finding or coming across this technology. And I always like the logistics part, and I think it comes in very handy at this stage of the company as well, with all of the supply agreements with the customers and that kind of thing. I feel comfortable with it.
So that takes me about the most exciting story you told me when we met. And, it will be amazing for everybody to hear how the synchronicity took place to take you guys from a toy trader to a bioplastic manufacturer. It'll be great to hear the story of what happened in China.
We used to take these trips to Canton, the famous Canton Fair, which is huge. To be able to cover it, you need at least like a week. One of those casualties in life, and very serendipitously, we as Guatemalans, we're coffee lovers, and you know that firsthand, Bed. But being in China and spending, this was 17 years ago around, and spending a little bit over a month for the toy and trading company, we wanted coffee. My mom wanted a cup of coffee. She was exasperated and really keen to get in her cup of coffee one morning. And she started asking, booth by booth, who knows where they sell coffee. And, this little guy stands up and says, well, I speak little English. I can take you to a McDonald's. And that trip to McDonald's, it became the beginning of this story of how we came across our partner and the technology. So at that time, he was exhibiting a booth for the University of Shanghai, specifically for the biochemistry department. And they had a first generation of a thermoplastic starch injected into a cube. And that cube, when he showed me that cube in the McDonald's, it looked like a plastic. It looked like something that you could mold as you would with a polystyrene or polypropylene. So that's where it sparked. Really thinking about what can I do with this material, and maybe I can do something interesting and impactful with this. And tying up to the thought of disposables not really being a disposable, it's a forever material. But they weren't thinking of applying this to something disposable. It was just like an injected thing. They were more thinking of automotive industries and stuff like that. And it was really me that started pushing our Chinese partner into, listen, look at these numbers. This is what food service companies are buying. This is what restaurants are buying. These are the volumes. These are the price points. And little by little, I started convincing him into, this is a good idea, to dedicate time to exploring this. So I guess that's how it all sparked. And I started with my first round of investment. We acquired the rights of this technology. And a little bit fast forward, I went to China for over 9 months and really learned how to formulate and compound these materials along with our partner. And at the time, I had my brother-in-law work for a fast food chain restaurant. And that was basically our pilot testing, was over a year and a half trying to develop the mold, the right cost, the right price, the right conditions. And after that, we formed this company with a Chinese partner that became what Borgani is today. This was the first generation of that technology. Now we're up to the ninth generation of the technology, and I would say pretty close to perfect. Of course, there's always room for continuous improvement, but right now it's performing like plastics. So yeah, it's a tremendous casualty that was well taken at that time, and the curiosity to keep exploring and seeing if this drove us somewhere, was proven to be right at this point. It's continuous improvement, I would say, and a lot of hard work. For the longest time, it was for the love of the sport, but now it's a profitable business.
It is also the conversation we had about necessity of strangers in our life, and how this one serendipitous synchronous meeting changes everything and how it evolves. But so you talk about 17 years back is when you met him, and then it took you almost maybe 10 or 12 years to launch Be Organi. So what were you doing in that phase, and was it just development over time, and then finally launching it? Tell me more about those years.
And the context of for the love of the sport, yeah, I had to work a couple of jobs in between because, as I said, this wasn't profitable. I didn't always have the backing of investors, so basically for a long time there it was just us without any fixed costs or overhead, trying to really launch this into an opportunity and not paying ourselves a salary. Then when we finally developed the first product, we started selling, but that wasn't enough to reach a break even. So for the longest time, it was just a struggle, in trying to find market, the right customer, the right volumes, and also a learning curve on handling a business. I would say that one of the main differences that I have now from back then is being able to really manage a business.
So you finally launched Beorgani, as your website says, in 2017. And is that when the money actually came in? And was that the point where you were ready with the technology? Is that the place where you felt that, okay, I'm ready to launch a commercial product and the money is there?
Yeah, a little bit. I formed a company before Biorgani that was focused in making only, compost home t-shirt bags for shopping and retail uses. I actually sold that company to my partner back then. 2015, I sold the company, and then 2017, I really made a good, elaborate plan with products that were ready to launch to the markets and really go to mass markets. The second time around, I did it right, with the round of investments, the assemblies, the protocolary needed things to create a company, the funding part, the R&D part. I have a 17-year baggage or experience in the biopolymer industry, but it wasn't Biorgani all the time. I've just been in different areas of developing biopolymers.
You have a 17-year track record of improvement. So tell me about your experience with investors and how you approached that, and how did you finally manage to convince some investors to come in and invest in Borgani, and what has their role been as you've gone forward?
Yeah, so at the beginning, it was a lot of what you mentioned earlier in the call, knowing people at certain moments and taking advantage of those opportunities that life presents you. But in the beginning, I was going to pitch our product to one of the companies that has the biggest impact in terms of pollution or visible pollution in Guatemala and in the region. And I pitched the product, and we started doing some R&D around their needs and their requirements. And it led to a conversation where, listen, I really like this concept. We have a fund of investment that's looking, to support green technologies, and this sounds like something that's attractive to us. And at that point, they saw that I was ready with the product, ready with the technology, and at the same time I was starting, so I needed the support, the capital support. It all got together, and it turned out I knew the family for that company. I knew them from back then, growing up in Guatemala. So everything worked, without forcing it. I was going to look for that round of investment, but it ended up being these investors. And so we started like that, with a first round of investment, and then the second round, we were a little bit more picky with, the profile of investor that you're looking for, because most of the times or sometimes, you end up needing more capital, or things are not exactly as what you planned. So you need a lot of understanding from your investors as well to be able to support you. So we handpicked our second investor, a big retailer in the region as well, looking to do an impact with a sustainable fund as well to support these types of startups. I gotta say, it's a very harmonious relationship what we have right now, not only in terms of putting up the capital, but they're really vested into doing something positive. They have these large businesses that are, polluting in some sense, trying not resolving the solid waste management equation. So this is a way for them to give back as well through these funds and supporting these kinds of startups.
Do you want to make sure you never miss an episode of the Good Garbage podcast? Click the bell on Spotify to turn on notifications and get an alert whenever we publish a new episode. Tap on the plus sign on the Apple Podcasts to follow the show and stay up to date with our latest episode release. Now, let's get back to the conversation. So let's switch gears a little bit. Let's talk more about the technology itself. The resin, I know you told me something about starch and this being different from the other starches.
Sure. So the first generations of our technology, as you mentioned, we use starch as a base component. So we're using corn starch because it's really widely available and massively produced in all the continents. But in terms of technology wise, we can use starch that's extracted from any organic based or renewable based material. So basically we can use potato starch, yam starch, sometimes rice husk as well, which is not starchy, but you can refine it. And then we started out as we were buying this first and second grade starch from the suppliers, as you would with edible starches. And as we moved along, and then we started getting some relevance and some traction in terms of the market, we started doing these inquiries of saying, listen, do you have waste starch? Do you have waste materials that you're not using? We're not using it to eat it. It's not edible. It goes with food contact practices, but you won't eat it. So if you have starch or waste product from your food primary processes, then we can very well work with that. And we started developing these sourcing relationships with a couple of strategic partners that started supplying the waste material that we needed. And in terms of being able to use that was a big differentiator in the market, because now you're not using the edible cornstarch, you're using the waste materials as a base component. And of course, there's other materials that we use, like to give you an example, a dextrine, which right now it comes from primary and secondary forms of corn. But I see the market quickly advancing toward using second and third grade corns and materials to extract that dextrine and glycerin. So it's moving along the lines of upcycled materials. That's a little bit of what we're using as a base component.
So I've had, and I don't understand starch that much, so pardon my ignorance. But when I look at materials, so we've had Ren who talked about tapioca starch, we've had Kevin who talked about cassava starch, and then we have corn starch and potato starch. My presumption is that although they are similar materials, but there would be certain differences. So can you just elaborate and educate me on how starches differ and how does that impact what you're trying to create?
Some of the things that you're looking for in terms of R&D and really implementing these materials into your polymer is density, to give you an example. So starting from density, a yam starch or a cassava starch could be a little bit heavier than what we're using in corn, and that has an impact on your biopolymer and how that translates into a finished product. And in the plastics industry, a normal density would be considered around 0.95 gram per cubic centimeter. What we're doing with this starch content and part of our continuous improvement process in R&D is how do we lessen that density weight of the finished product, not only because of cost purposes and efficiency purposes, but also because of recycling stream separation systems. Basically, advanced recycling involves separating materials through density in a tank of water. We don't want these materials to flow with a PP or with an HDPE because it would disrupt the recycling chain or the closed loop. To mention one thing, density differs, but also the grade of refinement that you can give it to, either potatoes or cassava or corn. They differ a little bit in those aspects. Technically, you can incorporate all of these starches into a biopolymer and it would convert into a TPS. It's what it's called, the category, a thermoplastic starch. But then digging deep into each and every technology, which are different, they have different parameters of processing, of storage, of handling. We all differ a little in the final application. So that's another thing, the percentage of starch that yields through each and every crop is different. So to give you an example, there's a cassava that yields 28% starch per pound versus corn that yields 18% starch per pound, and the husk that yields less than 10% per pound. So there's differences in cost equations as well in how you process this. Some of these starches have more cost in them than others. So I would say that looking for a good source that's stable in every area of what we're looking for in continuous improvement is basically what we do and our bread and butter.
So it boils down to cost benefit then. You are looking at something that's easily extractable versus more difficult to extract. But then I guess the base material costs are different. That if something is easily extractable, then it's probably more expensive. And then if something is more difficult to extract, then it's cheaper. How do you balance that?
And that's a good point. And actually, in practice, it's basically it's negotiations with your partner suppliers as well, and because they're gonna tell you, like, oh, I have to spend more time in processing this material versus a first grade grain. It's gonna cost me more, but at the same time, the raw material costs less. So it's a balance. It's like you said, it's a balance of where I can get the best value for our money and basically where can I get the best value for the biopolymer itself. Where is the market right now at, what the client is looking for, because you might do it with the primary form of corn, which is the most cost effective, but if you put it into a finished product, it might not result in the density you wanted. So it's a balance, and I would say that a lot of the flight hours invested in testing are exactly that, are testing each and one of the materials. What's the supply terms from that supplier look like? What's the relationship look like? The capacity output look like? The production for that resource, how does that look like? So there's a lot of factors that we need to analyze to be able to land on something that really works for you.
So, what is the business model? What do you actually source? Are you sourcing the starch from someone, or are you sourcing the corn or the husk and then compounding it?
Yeah, and I think we're on a path of vertically integrating towards making our own starch. We've started with lower volumes, but at the beginning, we sell the resin, the compound, already the pellet that goes into the extrusion process and, to be able to make a finished product. But before that, if you move back in the value chain, we started out with strong partnerships, that we're able to buy the grains and the husks and process it into a certain specification that we required for the bioresin. And slowly, that became an issue that we needed to address because big supply agreements require these customers to know exactly how much you have in the production run, how much you can supply, if you can commit to this or that. So that's how it started in terms of building a product that would allow us to create our own starch or to process our own starch. So we're slowly moving towards that way, buying the corns and the husks and the waste material from potatoes and yams, and processing our own starch materials or base materials. But our core business right now is to be able to compound and manufacture those pellets, that resin that later on translates into a finished product, a tray or a cup or a lid or something like that. What we do is we mimic what the plastics industry is doing in terms of being able to sell in gaillards, in full containers, 25 kilo bags, and mimicking the same operation, same process as you would have with conventional polymer. And that's basically us trying to adapt to the current manufacturing industry. It's we're not trying to change anything in terms of practices. We're trying to adapt our proposal to what's out there right now.
And this is something I learned the hard way as well. When you disrupt, don't just try and disrupt everything. Disrupt the product, but don't disrupt the supply chain. So that takes me really well to the amazing products that you're creating. And what I read and learn is it's all three areas, which is flexibles, rigids, and then food service, which is basically injection molding. So yeah, just talk to us in detail, as much detail as you can about your products.
Yeah, so we started out as a bioresin for flexible film packaging applications, specifically for blowing extrusion. So basically, we started with bioresins that could mimic a low density polyethylene. So it was a soft material that was able to blend with a low density, but was also able to substitute it completely up to 100%. So that's how we started because of clients' necessity, and basically that was the biggest pressure on our target customer list. But we slowly started identifying other opportunities that were well worth looking at, like the thermoformed applications and the injection applications. So our resource in terms of R&D was going towards how do we change the melt flows of the resin so that it can be either blended or it can substitute a polypropylene, to give you an example, in injection processes and in thermoform processes as well. So we started out thinking, okay, so if we're focusing on selling the resin itself and not the finished product, then like you said, like with one compound, we can tackle a lot of solutions. And that's exactly what happened. And when you think about the industry, our partners and ultimately our customers, which are the manufacturers of finished products, they're not manufacturing only one product. They usually have a wide range of solutions that they're offering to their customers. And what they would like to see is sort of like a one-stop shop in terms of, oh, if this polymer serves me for lids, cups, trays, and to cover a wide array of products of what we're doing, this is music to my ears. Because at one point the market was getting very specific that if you were doing products that are deeper than 1 inch, you needed one kind of resin. If they're deeper than 4 inches, you need another kind of compound. And our focus went towards centralizing and being as broad as possible with one compound. And that's how we came across the development of the thermoformable resins, which have to go through an injection process. Then they turn that into a sheet, and then that sheet gets formed into trays or food containers or lids, to give a couple of examples. But we're also doing the injection for the typical cutlery tableware that you see in the market, and we focused on disruptive solutions. So we're doing, to give you an example, we're doing a lid that is for mass product and retail product for instant coffee. So we started to focus towards not only the lid for prepared beverages, but what's happening with the retail industry and where is that going? Are they looking for solutions like the food service and prepared food, niche is looking for? And that led us to have disruptive solutions for the industry, not focusing only on the typical tableware for distribution.
So when you say there are different kind of resin compounds that are used for different applications, the blow film could be different, injection molding could be different. How does that differ? And then what did you do in order to sort of make a product that could be used for multiple applications?
Yeah, so in terms of base compound, it's basically the same. So the starch content stays the same with three range of polymers that we have. But then you start playing with bio-based materials like dextrins and glycerins, which really alter the melt flow index and other processability indexes of the resin itself. Even thermal stabilizers, because injection process, the material passes through the barrel for a longer time than in the blown extrusion. So we started discovering things in the process that we had to take them into the biopolymer in order for the product to work. And I could extend a lot on that, but I think that's the main idea on how we started finding different solutions and how we started working in the lab in terms of, okay, so I'm going to add a little bit more dextrin to this compound and see how that affects. It's a higher melt flow, but now I have a problem with temperature. So you start playing with thermal stabilizers, and that's the fun part of the business, I would say.
We would like to take a minute to thank our sponsors. Good Garbage is sponsored by Paka, a family of brands that produces compostable packaging and works to implement regenerative solutions. Paka's new project is to bring compostable food serviceware and food carry products to the North American marketplace. Learn more at paka.com. Now back to the conversation.
But when I look at each of these product ranges, they have two solutions. One is a quote unquote recycling solution, and the other is a home compost solution. So why go with both? Why not just stay with, say, compostable product?
On the recycling, our product and our resin is made to be compostable. Really, the main idea behind it is that you are able to substitute 100% virgin ethylene-based resin for 100% bio-based resin that will technically result in the same, but life cycle assessment will be very different than a conventional plastic in terms of circularity and recycling streams. So the general idea is for it to compost. And the compost home mark, we looked for that specifically because it's the most similar certification scheme to not requiring any waste handling, specific waste handling. So the big difference between home composting and industrial composting is temperature settings mostly and time. Because with industrial composting, you have 12 weeks, certain temperatures higher than 55 degrees. That doesn't happen in real life, at least in the countries that we launched, you never reach 55 to 65 degrees Celsius. So home composting is based on a 28-degree weather temperature setting, and it's 12 months or 280 days, something like that. So our solution is mostly adapted for that use. It's meant to be either composted or use nature as a natural catalyzer to really reincorporate our products into earth and not leaving toxins or dioxins behind. The whole blending came because first the molecules of our compounds tie up very nicely with the molecules of a polyethylene, and we were seeing that there's a sustainable economic transition in the market and with the brand owners that are not willing to go from 0 to 100, because of cost or because they're afraid of making a claim and seeing how it works. So the blending started out as a customer being conservative and saying, listen, I want to start out with a 20%. Does that impair the recyclability of our products? And we've successfully tested, with recyclers, that at certain rates for certain products, you wouldn't disrupt the recycling streams. But if you go higher than, to give you an example, at 50%, then you're disrupting the recycling streams because you have different densities. You don't have the same compatibility of materials once it's recycled. So it really depends on the solution. And it's amazing, but a film behaves completely different than an injected product, than a thermoform product. And a lot has to do with thickness and how that behaves in different environments. But that's basically how we came across of having customers that blend and having customers that use it at 100%. I would say that most of our customers are planning to go to 100%, and that's the ultimate goal. But they're just seeing where the market goes and where the trend goes.
Yeah, it's great to hear. And it's good to know that if you can't have 100%, at least start with 20. So that takes me well to, the cost and performance side. So let's take an example. Let's take like a film, a shopping bag. So if you look at a shopping bag, how does it compare when you look at the cost? And is there a compromise on performance in that case?
Yeah. So in that scope, on the shopping bag, it's a little less complex because it's not a product that has high barrier or specific requirements, that are tougher to hit with a bio-based compounds. But with a shopping bag, right now we're in some cases we have some parity examples, where it costs the same as a conventional plastic. And basically how we came across to do that is because of density. So we could find the perfect mix of materials and a compound that when you process it, it yields up to 25% more. So with a same kilogram of mix of bioresin, kilo per kilo, you're producing 25% more lineal meters in terms of film. Because the starch, when it's heated, it expands, and basically that expansion effect translates into the finished product. So with film, I would say parity to 5%. And then we have other complex solutions. So to give you an example, a thermoshrink film that's made to hold up to 5 kilos, sometimes even 8 kilos, 6 packs of 2-liter bottles, tough equations like that. The biomaterial doesn't necessarily add strength or performance enhancing characteristics. It's meant to add the sustainable part of the product. So in those cases, we have to do a slightly thicker film, so going 5% thicker to be able to match the performance of the conventional linear low densities. And like that, you have a lot of cases. But if you learn really how to identify where you have the best chance of being successful at implementing something that's parity, then you hit your sweet spot. And we've explored lots and lots of products over the years, and we're able to find some that are really interesting to our customers.
Yeah, it becomes a no-brainer if it's 5% or like at parity, then of course the customer knows that this is a good thing and they will jump. So a little more for my learning on when you say it expands more. So when you say expands more, does it have more coverage than ethylene?
It does, and it's funny, but it's similar to a popcorn effect. The contents of a popcorn, when it's heated up, it just blows up and expands. It's the same thing at a very, very tiny microscopic level. So the space that was previously occupied by a polyethylene molecule that is now occupied by a starch that is heated, you find a way to occupy more space with less weight. And that's basically what's behind the finished product solution. And when you see a film, and it's amazing to see, but when you see a film that's the same thickness and you weight one per one, then you're seeing the advantage. And it's one of the best practical tests that I can do to a customer. Listen, compare the thickness, compare the strength, the performance, now weigh it and see the differences. But it's really from that common concept of expansion into starches.
So that's a great analogy. The second thing you said, which was also very interesting for me, is why is it that the bio-based products don't have the similar barrier properties? What causes that?
So speaking of our material specifically, the starch being porous and powdery, it doesn't bring in high barrier or humidity or oxygen barrier characteristics to a film or a blown injected product. But there are some technologies in the bio-based industry and more so up and coming. So like the seaweed cellulose that we were discussing previously, that has high potential, to have the same barrier characteristics that you would get from a PLA or a PHA or a PP or a polypropylene. So depends on the material composition that you're using and what you are going to use it for. I don't think the bio-based polymer industry is at the point where you have a wide a range of options in terms of high barrier solutions. You have a few that's out, that they're out there, and they're actually you can buy them for a acceptable cost and price, but there's not that many. There are much more options up and coming, but the plastics industry, we need to consider that it's been here for since 1950 basically, and so it's had over 70 years to improve in terms of material and performance characteristics. And bioplastics started out really exploded in the 2000s, and really we've had less time to really get to a point where we can match some of these performances. But there are up and coming companies and technologies with exciting things and stuff that we can even use in our own compounds as well to get that continuous improvement or offer different solutions than what we're offering right now.
Yeah, you're right. And talking about the markets and the customers, I know that you're working with some really, really high quality customers. And you mentioned the lids. I know that's a significant global company. Tell us more about the acceptability of the product and how that has been and how you've felt in terms of the markets being ready for your products.
Sure. So I think there's a big driver of change nowadays, and I think it's sort of like a new currency. But when you talk about carbon emissions and carbon footprint, that for us in the space is super positive, because now the clients and the brand owners, big companies, are starting to really understand this concept of carbon emissions and how you can offset your carbon emissions and what you can do to offset your carbon emissions. So when brand owners and companies started speaking this language, you become basically a vehicle for carbon emission savings versus virgin materials and things like this. So when you start talking that language with the brand owners, I think there's more to it. Like there's a whole more sense to the solution that you're offering, not just this is gonna compost or this is gonna biodegrade over time. This is actually helping you reach your targets that you signed through pacts to 2025, 2028. So we become a vehicle that brings up a solution for them, for the companies, for the brands, and really trying to understand what's happening. Okay, if you're selling, to give you an example, in Europe, the disposal of the same product is not the same as selling in Guatemala. So being able to adapt different solutions to different realities, that part of the dialogue is more accepted now with brand owners, and they're happy to extend on that dialogue. And I think that's very positive for us in the space. And it's been a big driver. It's been a big driver for change.
And are you seeing that percolating down organizations through to the purchase head kind of level, or do you still have to make sure that you are able to access the C-suite to be able to make that argument?
Some companies have it down into management and buyers. It's become a second language to some of these companies, especially the ones that have signed pacts. There's a famous pact, the Ellen MacArthur Foundation. It's a pact for 2025 to go either 100% recyclable, 100% reusable, or 100% compostable. So it really depends on the profile of the company. You either have big companies that understand it very well, or small companies that the owner is leading it and he understands it and it's easy to get the concept in. I would say the toughest nutshell is in the meat part, and really how to get them to understand that all of these big guys and big brands are talking about it. And that's not a generality. There are many companies in the mid tier level that are starting to understand this and that are leveraging this in order to get more market share and more acceptance. But that's on our experience. That's how we are seeing the buyers and the executives evolve.
So we have a big challenge to overcome in terms of scaling, raw material processing, and then the market. So if you are to imagine the next 5 to 10 years and be organic, making a huge impact. So how do you see that possibility of being able to source material, process material, and access the markets and ensuring that that happens? How are you planning that?
In terms of the sourcing, that's one of the main reasons why we're sticking with corn, and going towards waste materials that are derived from corn, just because it's widely available. If you Google, where is corn massively produced, you'll see the map of where it's produced, and it's everywhere. And so, in terms of sourcing the material, we don't see any shortages anytime soon. The challenge here is basically the middle part. So us being able to process those volumes to be able to comply with the supply agreements that are required. And of course, we would want to enter with a lot of brand owners and the usual suspects with the highest consumptions of resin. But in reality, it's not like that. It's a limited resource, it's a limited production capacity. So our approach to that is really having this committed partnerships and relationship with our customers in terms of, okay, I'll set up, I'll do my sourcing homework, I'll do my processing homework, I'll do all of this, but I need your support in terms of, if of course, if I'm compliant with your requirements, I need long term, I need security, and these things, that you have to really put in the table to create strong partnerships towards growth. At some point, at some point, we could be massified on another level, but for now, you have to basically cherry pick your opportunities and be able to guarantee your base of customers that you're not going to fail them, because this is a new field and space, and we're not the usual suspects that are refining polymers that have been doing this for years and decades now. So it's a risk for them as well. So everything you can do in terms of insurances, getting the right people, getting the right processes, machinery, all of that adds up to how strong your partnership can be with your own customer base.
And as a business leader, is there a dream that you're pursuing? Is there a certain million tons or whatever 1,000 tons that you want to see in the next 5 years to happen for Be Organi?
Being a little dreamy about this, and maybe you can ask me this question in a year or so. But yeah, we do have a 3 to 5 year objective in being able to push out at least 2,000 tons per month. That's the ambitious goal. Of course, that is small scale if you compare us to one of the leading brands in conventional polymers. But that's what we're trying to do. We're now doing less than 1,000 tons per month. I think if we can reach that point, I'll be a happy man, and I'll be happy that really we're having an impact that's meaningful. And after that, it really depends on the path that we choose to go to, and I think it's feasible. I think there's a scale and a volume where you can reach 10,000 tons a month. But from 2,000 to 10,000, there's a lot of things that we need to work on, and a lot of processes and continuous improvements.
What you've done, I think, is the harder part. I can assure you that the path from here is a lot easier. I think it's the creation and finding that niche that really takes a lot of blood, sweat, tears, to come through to this, and then to scale up. Yes, it's exciting and it's tough as well, but it's not as tough as what you've already done. So what you would find is that going from 1,000 to 10,000 will be easier than going from 0 to 1,000.
I hope so, Ben. I really hope so.
I assure you that is what you'll find. And so, okay, taking me to my last question, and of course, happy to have you add anything else that you want to add in case I've missed something. But what does good garbage mean to you, and how would you like to see good garbage in the future?
Good garbage, that's congrats, because I think that's a perfect name for this program. When I hear good garbage, I just hear value. There's value in good garbage, and I think there's a strong trend, not only in circularity and recycling, but there's a strong trend of getting upcycled materials, as your base component for these solutions that we're trying to offer the world. I think the path towards getting something that wasn't considered as a valuable, and turning that into a valuable, it's art. I think it's great. I think it's part of the movement also of really taking advantage of the resources available and not wasting what's around us. And I think that level of conscience is only making progress. And I'm happy to be a part of that equation. When we take waste materials to incorporate into our biopolymers, that's basically what we have in mind. And hopefully we'll get to a point, and basically we have a 2-year plan to get there, where we're 100% upcycled materials. We're now 50%. But I think as the market grows, as the scene grows, as the space grows, we'll be able to implement those solutions, and take it good garbage and turn it into packaging.
That's amazing. It's really well put when you look at the actual input material. Normally, we immediately jump to the final result of the packaging, but I think it's really interesting to hear about upcycling material, and that's what good garbage means. Gabriel, you are an inspiring man, and I thank you for the possibility of being able to talk to you. Thank you for being on the show. This means a lot to all of us as humanity, and I wish you all the best, and I wish that we will see bigger and bigger impacts being created by Borgani. Thank you so much for being on the show.
Ben, it was a pleasure for me to be here. It's good to find a space where you find people with the same affinities. It's really a pleasure meeting you. It's inspiring to talk to you, and thank you for having me.
Thank you for listening to the Good Garbage Podcast. Follow us on social media to never miss an episode. Links are in the description below. I'm your host, Ved Krishna. See you next time.